This morning, we're going to discuss Module 6. This is heat and temperature. So the most essential learning competency is to differentiate between heat and temperature at the molecular level. So at the end of this session, you are expected to differentiate between heat and temperature. Second, identify the direction of heat transfer. And third, convert temperature scale to another temperature scale. So these are the questions that I think this will guide us also in our discussion. So if we can answer all of these questions, I'm very sure that you learned about the lesson and we hit the target, the MELC. Okay, first question. What is the difference between heat and temperature? Second question, about the heat transfer. When does heat transfer happen? And number three, what is the direction of heat transfer? And number four, how? How to convert temperature scale to another temperature scale. Okay, let's start with the first question. What is the difference between heat and temperature? So what do you see in the pictures? First picture is a child having fever. So what do you think is the best way to know the temperature of the child with fever? So maybe we can use thermometer, no? Or if we don't have thermometer, we'll just touch the forehead and feel if it is hot or very hot or not so hot. Another picture showing the frying pan with oil. So to test the hotness without using thermometer, we can test also that by as by sprinkling the water on the oil to see if it is enough for us to start frying anything. Okay, and the third picture shows the baby bottle with milk. And to test the hotness and coldness of this, maybe we can put or drop some amount of milk in our wrist. Okay, so these pictures shows hotness and coldness. So if you want to know the hotness and coldness of an object, we're going to use an instrument, thermometer. But what is temperature? When we say temperature is a measure of hotness or coldness of a body or object. And temperature can be measured using a thermometer. So, according to the kinetic molecular theory, all matter has molecules or atoms. And these molecules are constantly moving. So what causes the motion of the molecules and or atoms? This is because molecules have kinetic energy. So these are the types of thermometers or different kinds of thermometers. Actually, thermometers could be have two types. We have the room thermometer and the body thermometer. We cannot use the room thermometer for knowing the temperature of the body, but it is used to measure the temperature of the environment, the room, the substance you are going to study, like for example in the laboratory or if you have an experiment. We can use the thermometer to test the temperature of the substance like liquid, okay? Or if we have a what they call this one, field trip, and you are asked to get the temperature of the environment, you're going to use the room thermometer. The body thermometer is another thermometer that is used to measure the temperature of our body. Okay. In this picture, you can see different kinds of thermometers. We have first the body thermometer, second digital, and this one. Alam nyo ano to? What kind of thermometer? This is a mercury thermometer, having a liquid mercury inside the thermometer. This one is an alcohol thermometer. So before, our school provide a mercury thermometer, but this time, mercury thermometer is not advisable to be used. Only alcohol thermometer is provided for us because mercury is dangerous to our health as an effect. If this mercury keep in contact with our skin that has wound, for example, so this is very dangerous. So mercury actually is not advisable anymore this time for the use, but only alcohol thermometer. This one, are you familiar with this? You can see this one in the mall. Before you can enter the mall, you can see this uh, thermometer used to measure the temperature of the persons before they can enter the malls or any establishment. This one is another kind of environment, room temperature. Okay, so thermometer is a sealed glass tube containing mercury or alcohol with a temperature scales imprinted on it. So, maano siya ang mga thermometer. We have the scales, and then inside, pwede siya mercury, pwede din siya alcohol. So, what happened to this alcohol? This will rise and then down, right, and then down, depending on the what type of substance or temperature is your substance. Okay, so the first, in 1654, the first thermometer was invented by Ferdinand II, the Grand Duke of Tuscany, invented the first thermometer that was liquid alcohol in the is used in the thermometer. But this approach was not still accurate because there is no standard used in scaling. But another scientist in the name of Daniel Gabriel Fahrenheit, a German physicist in 1724, also modified another thermometer, but this time he used mercury and has a standardized scale. So meron ng scale yung ginawa ni um, Daniel Gabriel Fahrenheit. Then, so balikan natin ang kinetic molecular theory since we are asked to describe the molecular level, the kinetic molecular theory, that all matter has molecules or atoms that are constantly moving, and the cause of these atoms are is because of kinetic energy. So let us see, this is a gas. This is the molecules or atoms of gas, then liquid, and then solid. So we all know that the particles in solid are compact, very close to each other. But it doesn't mean that the particles don't move. Still, still, the particles are moving. Even they are very compact, very close to each other. In what way they move? In the form of vibrations. So in solid, the particles will just vibrate. So just stay in that position and vibrate. So still, the particles in solid are moving. In liquid, they also move in a form of nudging. Nudging means colliding. Okay, since in liquid, the distance between particle to particle is not so close compared to solid, so their movement is nudging or they just collide. In gas, since the distance between particle to particle is very great or very high distance, so they move in all direction. Okay, so what caused the movement of these particles? It's because of the kinetic energy. Okay, and the faster the molecules move, the more kinetic energy they have. So in the picture, in the illustration, we can say that we can see that in a colder, the molecules are moving slower. And in the warmer side, the molecules are moving faster. Okay, the more kinetic energy they have, the higher the temperature. So they move faster in warmer. This is because the molecules gain kinetic energy. Okay, the molecules that move slower, the molecules move in slower in colder. It's because they lose kinetic energy. So take note that if the temperature is very low, the motion of the particles is slow. If the temperature is high or warmer, the movement of particles is fast. Okay, another definition of temperature is a measure of average kinetic energy of molecules. So what does it mean? So a gas sample, for example, consists of 100 particles, and each particle has a kinetic energy of 2 joules. For example, can we now get the what is now its temperature and what is now the total kinetic energy of the substance? Okay, this is how to get the total kinetic energy of all particles in a substance. This is actually referred to the internal energy. So the name of the total kinetic energy of all particles in a substance is what we call as internal energy. The symbol for internal energy is E. Okay? So the equation for internal energy or the total kinetic energy of all molecules is E is equal to summation of kinetic energy. Okay, so how to solve the total kinetic energy? To solve the total kinetic energy of all the molecules, we'll just follow the equation. Okay? 2, 2 that is the kinetic energy per particle of each particle times how many particles? 100. So 2 times 100, the answer is 200 joules. Meaning, 200 joules is the total kinetic energy of all particles in a substance. Okay, that's the E or internal energy or the total kinetic energy of all particles in a substance. So we answered already question number 2. What is the total kinetic energy? So you will have to add or sum up all the amount of joules in a substance by multiplying the amount per particle times the number of particles, and that is the total kinetic energy. The second question is, what is its temperature? Okay, so based on the definition of temperature, it is the average kinetic energy of molecules. So to get the temperature of a substance, the equation is T, which stands for temperature, equals E divided by the number of particles. E is the total kinetic energy of all molecules in a substance. So we have already computed the total kinetic energy of all molecules in a substance, and that is 200 joules. So substitute now the value of E, the total kinetic energy, which is 200 joules, divided by how many particles? And there are 100 particles. So 200 divided by 100, that's the number of particles. That will give you 2 degrees. That is the temperature of the substance. So it depends also what scale are you using. If you are using Celsius, 2 degrees Celsius. If you are using Fahrenheit, 2 degrees Fahrenheit. Okay, let's proceed. So this is actually the solution for the problem number 1. So temperature is a measure of the average kinetic energy of all molecules in a substance. So the total kinetic energy divided by the number of particles, that will give you 2 degrees. But take note, temperature is not an energy. It is the hotness and coldness of the body. And the unit of temperature is in degrees Celsius, degrees Fahrenheit, or Kelvin. Okay. Question about temperature before we proceed to the meaning of heat. Okay, Nan. Okay, let's proceed. What is heat? Okay. In early theory of heat, the theory on the caloric theory, it says that this theory said that heat is an indivisible fluid, a indivisible fluid called caloric, that flows between objects with different temperature. So before this theory found out that there is a fluid called caloric that flows or transfer from one object to another due to or because of the difference in the temperature. Okay, meaning that this caloric is transferred from one object to another. Okay, so this is same thing with the um, but another side, James Prescott Jones superseded. What do you mean by superseded? Superseded means na nalamangan niya, na anuhan niya yung theory ng caloric. And he studied the nature of heat. He discovered that the amount of mechanical energy of heat is, which is 4.186 joules, is equal to 1 calorie. Okay, so therefore we can say that heat is another form of energy. Okay, so heat is an energy, and the unit of heat is in joules. Okay, diba? Before we studied about energy, the unit of energy is in joules. And joule is the unit of heat as the standard international unit. So this is the standard international unit. International standard unit of heat is joules. But there is also a common unit. The common unit of heat is in calorie. Okay, so the unit of heat is in joules and in calorie. Joule is the standard or international standard unit, and calorie is common unit. What is calorie? Calorie is defined as the heat needed to change the temperature of 1 gram of water by 1 degree Celsius at a pressure of 1 at atm. ATM is atmospheric. This is the unit of pressure. Calorie is not used to refer as the amount of heat, but it is used by dietitian, nutritionist to specify the energy content of food. Okay, so calorie specify the energy content of food. So we can say that heat is an energy in transit. Transit means heat will transfer from one object to another. It will not stay in one object. It will transfer from one object to another. And the flow of heat is from hotter object to the object with very low temperature. So take note of this. The movement of heat is from hotter object to a low temperature. So heat is defined as a thermal energy that is being transferred from one object to another because of the temperature difference. So what caused the heat transfer? This is because of the temperature difference. Kaibahan ng temperature. Okay, this is an example of how heat transfer is, how heat transfer occurs. Okay, so we have three objects. First object, the object A is 65 degrees Celsius. Object B is 0 degrees Celsius. And object C is 100 degrees Celsius. Okay, so meaning object A is warm. Object B is cold. Object C is hot. Okay, my question is, can you describe the heat transfer from one object to another? Okay, this one. From object A, which has 65 degrees Celsius, and object B with 0 degrees Celsius. What do you think is the correct direction of heat transfer? Is it to the right or to the left? The correct arrow between the two objects. Remember, heat transfer starts from high temperature to low. So object A will have a temperature of 65 degrees Celsius and object B is 0 degrees Celsius. So what do you think is the correct arrow? Is it to the right or to the left?
To the right, ma'am.
Okay, this one. Ito na arrow.
Yes po.
Check. Very good. So this is the direction of heat transfer. Okay, the direction of heat transfer is from greater temperature to a lower temperature. So you're correct. Very good. How about this one? 65 degrees Celsius, the object A, and object B is 0. Ano? This is the answer. Okay, number 2. This one. 65 ang object A, 65 degrees Celsius, and object B, 100 degrees Celsius. So what is the direction of heat transfer?
Left po.
Okay, very good. So The answer is this one. Check. Ang galing naman. Okay, this one. What is the direction of heat transfer between object A and object B? So object A is 0 degrees Celsius and B is 50 degrees Celsius. To the right, to the left.
Left po.
To the right,
Left po. Left.
the left. Very good, Laika. How about number two question? What is the direction of heat transfer between object A and C? Oh, this one. This is object A and this is object C. To
Ma'am, si
the,
Jessica.
what's the direction? Right
The
to
left
the
po.
to the left. Very good, Laika. Next, number three. The
Ma'am,
direction
si
of heat
Jessica.
trans-
Man to, ma'am.
Ay, sorry. Si Jessica di makita ang mga ano din yung mukha. Makita ko lang kay presentation ko. Okay. Number three. What is the direction of heat transfer between object B and object C? Oh, dito sa dalawa. To the
To the
left
left.
naman. Okay? Kasi higher ang C and then lower temperature ang B. Okay, heat transfer takes place between object of different temperature. Okay, so ito yung condition why there is heat transfer. This is because of the difference in the temperature. And the heat transfer and the heat is transferred from an object of high temperature to an object with low temperature. Okay, the object with high temperature actually is the one that gives off heat. Okay, siya ang nanghatag. And the object with low temperature is the one that absorbs heat. So siya ang nag-receive. So in the heat transfer, this is what we call, there is what we call as giving off and accepting heat or absorbing heat. Okay, usually the object that has a high temperature is the one that gives off heat, and the object that has a very low temperature is the one that absorbs heat. So how is heat transferred? Okay, paano ba i-transfer ang heat? Okay, there are three ways. I think your grade 7 teachers discussed already this one. Can you remember the conduction, convection, and radiation in grade 7? Diba? Discuss nyo na to sa grade 7. So, recall lang natin. So, conduction is a way of transferring heat by direct contact. So, let us see, for example, this hot object. If you want to have a transfer of heat, okay, hawakan mo directly. You have a direct contact. So, the heat, the energy will now transfer to your hand. That is for conduction with direct contact. For convection, heat or energy is transferred by the mass motion of molecules. So, for example, this one, palapit ka lang. Okay, like for example, mayroong source of fire. You will not have a direct contact. You will not touch the fire, but have a transfer of heat by the mass motion of the air molecules. So, parang di pa, ano lang sa'yo. That is convection. Radiation is energy is transferred or heat is transferred by an electromagnetic radiation. So let us say for example, exposed ka lang sa sunlight and there is a transfer of heat by electromagnetic radiation. Okay, so there are three common temperature scales. One of these is Celsius. This is introduced by Anders Celsius in 1741. So in Celsius, the freezing point of water is 0 degrees Celsius. And the boiling point of water in Celsius is 100 degrees Celsius. With an interval is when we subtract the boiling point 100 degrees Celsius by the freezing point 0 degrees Celsius, we'll have an interval of 100 degrees or 100. So this difference between this temperature references point is divided equally into intervals, and that is what we call as degrees. Okay, second temperature scale is Fahrenheit. This is introduced by Daniel Gabriel Fahrenheit in 1724. So the freezing point of water in Fahrenheit is 32 degrees Fahrenheit, and the boiling point of water is 212 degrees Fahrenheit. So what is the interval? If we subtract the boiling point 212 minus the freezing point 32 degrees Celsius, you will have an interval of 180. So again, the difference between these two different points is divided equally into interval called degrees. The third temperature scale is in Kelvin. This is introduced by William Thomson, also known as Lord Kelvin. And this scale is based on the absolute zero that is corresponding to the 0 Kelvin. So it is the slowest possible temperature and it is when the molecules of substance have the lowest energy. The freezing point of water in Kelvin is 273 Kelvin, and the boiling point is 373 Kelvin. So the temperature difference is 373 minus 273. The answer is 100 Kelvin. So this is the interval. Okay, when are we going to use degrees Celsius, degrees Fahrenheit? Okay, you're going to use this symbol if you're going to report the temperature of an object. So for example, 100 degrees Celsius. But if you're going to use this symbol Celsius degrees or Fahrenheit degrees, you will use this one for the temperature difference or the change in the temperature. So for example, you are asked to give the interval or the temperature difference of in Celsius. So you will say 100 Celsius degrees. Okay? Or 180 Fahrenheit degrees. Okay? And 100 Kelvin. So see the difference, how to use degrees Celsius, degrees Fahrenheit, and Celsius degrees and Fahrenheit degrees. Alam niyo na kung paano gagamitin. Take note, pag temperature, gagamitin mo ang symbol na degree Celsius or degree Fahrenheit. Pero pag sasabihin sa'yo the temperature difference or change in the temperature or the interval, so unahin mo muna sulat ang C or Celsius bago ka mag-degrees. Okay? Question. Nan?
Wala naman.
Okay. This is the summary of the boiling point and the freezing point. So the boiling point in Fahrenheit is 212 degrees Fahrenheit. And the freezing point in degree Fahrenheit is 32 degree Fahrenheit. So when we subtract 212 minus 32, you will have a 180. So paano isulat? So ganito 180 Fahrenheit degrees. Or katugan this one Fahrenheit degrees. That's the difference, degree Fahrenheit and Fahrenheit degrees. Okay, Celsius, the boiling point is 100 degrees Celsius. The freezing point is 0 degrees Celsius. Subtract 100 minus 0, you will have a 100 Celsius degrees. in Kelvin. The boiling point of water in Kelvin is 373.15 Kelvin, and the freezing point in of water in Kelvin is 273.15 Kelvin. So when we subtract 373.15 minus 273.15, we'll have an interval of 100 kelvins. So ganito magsulat ng degree Celsius kung temperature siya. Kung intervals, ang gagamitin mo na is 180 Fahrenheit degrees, Celsius degrees, Kelvin. Okay, question about this one. None? Okay. So, in Fahrenheit, water freezes at 32 degrees Fahrenheit and boils at 212 degrees Fahrenheit. In Celsius naman, water freezes at 0 degrees Celsius but boils at 100 degrees Celsius. Okay. So, uh, the change in Fahrenheit divided by the change in the temperature in Celsius is equal to, if we're going to subtract 212 minus 32, the answer is 180. And the change in degree Celsius is 100. Where did I get this 100? 100 minus 0. That's the freezing point interval and the boiling point interval in Celsius. That is why 180 divided by 100. Meaning, change in degree Fahrenheit divided by the change in temperature in Celsius. So you will have 180 divided by 100. So if we're going to get the lowest term of this, we're going to divide it by 20. So 180 divided by 20, you will have 9. 100 divided by 20, you will have 5. That is why in the equation, we have 9 over 5. Okay? And that is 1.8. So what does it mean when we have 9 over 5 or 1.8? What does it mean? Okay, this means that a 1 degree step in Celsius is a 1.8 degree step in Fahrenheit, or 1 degree step in Fahrenheit is 0.56. That is 0.56 step in Celsius. So the equation in getting or in converting Celsius to Fahrenheit is this one. Kaya nagkakaroon ng 9 over 5 in the equation. Kinuha yan dito. Okay? So to get the equation for Fahrenheit, if the Celsius is given, is 32 plus 9 over 5 times the amount in Celsius. So ito yung formula, ito yung equation na gagamitin natin pag given ang Celsius. Okay. Ito naman ang equation for Celsius, meaning given ang Fahrenheit and then you are asked to convert it to Celsius. So the equation is Celsius is equal to 5 divided by 9 times Fahrenheit, the amount in Fahrenheit, minus 32. Okay? So, asan kinuha yung 9 over 5? Kinuha yan dito, 9 over 5 or 1.8. Okay. So, in your module, the equations are given. We have 1, 2, 3, 4, 5, 6 equations in converting one temperature scale to another. The first one is, you're going to use this equation if the Fahrenheit temperature, TF is temperature in Fahrenheit, TC is temperature in Celsius. So to convert the temperature in Fahrenheit to temperature in Celsius is, you're going to use this equation. 9 over 5 times the value in Fahrenheit minus 32. Okay? Another equation, if the Celsius temperature is given, and you are asked to convert it to Fahrenheit. So you will use this equation. So temperature in Fahrenheit is equal to 9 divided by 5 times the temperature in Celsius plus 32. Okay, this one also is another equation in converting temperature Celsius to temperature Kelvin. Okay, the equation is temperature in Kelvin is equal to temperature in Celsius plus 273.15. Okay, another equation. If you are asked to convert temperature Kelvin to temperature Celsius. Okay, so the equation is temperature in Celsius is equal to temperature in Kelvin minus 273.15. Okay, another equation. If the Kelvin is given and you are asked to convert that to Fahrenheit. So this is the equation. Temperature in Fahrenheit is equal to 9 divided by 5 times the temperature in Kelvin minus 459.67. What if the temperature in Fahrenheit is given and you are asked to convert it to Kelvin? This is the equation. Temperature in Kelvin is equal to 5 over 9 times the temperature in Fahrenheit plus 459.67. So please take note all of these equations because we're going to use this one in converting one temperature scale to another. Okay, so we'll have a problem solving number one. Okay, sample problem number one. What is the human body temperature, which is 37 degrees Celsius, in Fahrenheit scale? And then in Kelvin scale. So meaning, in the problem, you are asked to convert 37 degrees Celsius into Fahrenheit scale and Kelvin scale. So this is the solution. Okay, given. The given is 37 degrees Celsius. So convert that to Fahrenheit. So kung balikan natin yung mga equation, ito yung equation na gagamitin natin. Given ang Celsius, you are asked to convert to Fahrenheit. So the equation is temperature in Fahrenheit is equal to 9 divided by 5 times temperature in Celsius plus 32. Substitute the value. The value of temperature in Celsius is 37. So, can you get your calculator? Ang gawin mo is 9 divided by 5 times 37 plus 32. Or 37 times 9 divided by 5. The answer is 66.6. Then you add plus 32. So, answer dapat is 98.6. Did you get the answer in your calculator? 98.6. Ah? Laika? Okay, very good. So, meaning, tama yung pag-compute mo. And then, round off that one to a whole number. So, since it is 98.6, this becomes 99 degrees Fahrenheit. This is the answer for question number 1. Okay. Question number 2, you are asked to convert that into Kelvin. So the given is 37 degrees Celsius and then 2 Kelvin. So what equation are you going to use? So this is the equation. The given is Celsius and then Kelvin is unknown. The equation is temperature in Kelvin is equal to the temperature in Celsius plus 273.15. Substitute the value in Celsius, which is 37. 37 plus 273.15, and the answer is, in your calculator, What's the answer in your calculator?
310.
Very good. So that's the answer for Kelvin. But you need to round off this one to a whole number. What's the value in a whole number? 310.
Yes.
But don't forget to write the unit. 310 Kelvin. Same thing with the number one answer. There should be a unit. Because pag walang unit, meaning hindi yan ang correct answer. There should be a correct unit. Okay, so 99 degrees Fahrenheit. And second answer is 310 Kelvin. Okay? Question on how to convert. Ang clue lang dyan, class, know what is given and know what is asked. Okay, and then substitute and then follow the equation kung subtraction, multiplication, or division. Okay. Next topic, let's proceed. So the effects of heat. So when heat is added to a body, there are various things will happen. So ito yung mangyayari when we add heat. Thermal expansion, temperature increase, and change in the phase. So ito yung mga effects of heat. Let's start with the thermal expansion. So most of matter expands when heated and contracts when cooled. So an example of this is boiled egg. Boiled egg that crack and thick glass crack when hot water is poured onto them. Pag i-boil na natin ang egg, bakit kaya mag-crack? At saka yung mga thick glass, bakit kaya sila mag-crack pag i-pour natin yung hot water? Okay, this is because of thermal expansion. So what happened to the molecules if we add hot water or heat? We add heat. So what happened to the molecules is it will gain kinetic energy. So the molecules will now start moving and moving. So what happened to the distance between particles and particles? The distance between particles and particles will now increase. So they will now occupy a greater space. So what happened is the volume, the space occupied by the particles will increase. That is why the boiled egg crack. So there is what we call as expansion. Okay? The same thing will happen to the particles of glass. So what happened to the particles of glass is it will gain kinetic energy. So the molecules will now start moving and will have a distance of greater than before. Greater than before we add heat. So since the distance now is increasing, since they will occupy a greater space, the volume will now increase. So if the volume will now increase, what happened is it will have a thermal expansion. Okay? So same thing happened also to the metal lid cover of a bottle. So bakit kaya pag ang jar na merong metal lid cover, lalagay natin sa ref, bakit pag kunin na natin yan, i-open natin, the metal lid cover will stuck on it. Mahirapan tayo mag-open. This is because when the particles of metal lid cover is exposed to a very low temperature, what happened to the particles is they will stay and compress So what happened is the distance between particles and particles will now be closer. So what happened? So nagliit. Ibig sabihin, nagliit ang metal lid cover. So kung nagliit siya, nag-stuck siya doon sa mouth of the glass. So mahirapan tayo mag-open. So what do you think is the solution to open the metal lid cover easily based on the thermal expansion concept? Ano kaya ang best thing na gagawin natin para mas madali natin ma-open ang metal lid cover? Laika, na alam na natin na pag expose pala ito sa high temperature or when we apply heat, the molecules will now start moving and will occupy a greater space. So what happened is they will expand. So anong gagawin natin para mas madali natin ma-open yung metal lid cover? We'll have to pour hot water. So, i-pour natin yung hot water. So, what happened kung i-pour natin yung hot water sa metal lid cover? They will expand. Okay, it will expand. The particles now will now start moving, occupy a greater space, so the volume will now increase. So what happened is they will expand. Dili na siya mag-stuck sa mouth. So muluag na siya kasi nag-expand na siya. So it is now more easier to open the bottle. This is what we call as thermal expansion. Okay? Next. So in a thermal expansion, in an expansion, when water is heated, the particles of an object will now start vibrating more. So more apart, they will move apart and so they occupy more space. So the size and the volume will now increase. But take note, the size of the particles will not increase. They will just remain the same. So wala ning dako ang mga particles sa take note. Only the space occupied and the size. Okay, so kung titingnan natin dito, hindi naglaki ang mga particles. Okay? The size of the particles remains the same. Only the amount of space occupied is increased. This is what happened kabaliktaran pag the object is cooled. Okay, pag i-expose natin ang object sa very low temperature, what happened is the particles of object will now slow down. Okay, so they move and become a very close distance. So the particles will have a close distance. So they will just na-compress siya. Okay? So, another example is pag mag-boil tayo, class. Mapansin natin ang volume ng water before we boil is ganito lang. What if after applying heat, it will increase? And then later on, mag-overflow na siya. This is what we call as thermal expansion. So what happened to the particles of water? They start moving. So that when they move, they will occupy a greater space. So the volume will now increase. Okay, so this is what we call as thermal expansion. Okay? Another example is when the alcohol or mercury in the thermometer rise and goes down. Thermal expansion din yan. Okay, so what happened? If we're going to dip the thermometer in a very low temperature, what happened is the molecules of the alcohol or mercury will gain a lesser kinetic energy. So they will move in very slow motion. So they will have a lesser distance between particles and particles, so they will compress. So they will occupy a lesser volume. So they will stay on the bottom. Okay? Magbaba ang iyahang uh, alcohol. Okay? So, ang volume niya magbaba. So, mapansin natin sa temperature, mubaba siya pag i-dip natin sa very low temperature. But when we dip the thermometer in a very high temperature, we observe that the alcohol will rise. This is because the particles will now occupy a greater space. So, the volume now will increase. So, mag-rise na ngayon ang alcohol or mercury. So, the increase in size of the object actually is due to the increase in the space, increase in the volume between particles. And the increase in size of an object when they are applied, when they are in hot, they are in exposed to a very high temperature or a greater heat is what we call as expansion. And the decrease in size when they are cooled is what we call as contraction. Okay, expansion when there is an increase in volume and size, and then contraction if there is a decrease in volume or in size. So, kailan mag-expand? Pag ma-expose sa greater temperature. Kailan mag-contract? When exposed to a lesser temperature. Okay, another example of thermal expansion is sa car tires class. It is advised not to overinflate the car tires of vehicle. Why? This is because when the tire is exposed to a very hot temperature, like for example, magtakbo na siya, so maanhan siya, is exposed to a very high temperature, what happened to the gas inside the tire is they will expand. So kung i-overinflate mo siya and then mag-expand, so what do you think will happen to your car tires?
Buto mo.
Oh, very good. So, dapat hindi natin i-overinflate. Okay? Give space for expansion of the particles inside the car tires. Another one, gasoline tanks should not be filled to the brim. Dili kaayo dato na po up to the kaning brim na jud niya. It's because the gasoline particles will expand. So pag mag-expand yan, what do you think will happen? Nawala na siyang space na i-occupy. What do you think will happen? Pwede siya
Overflow ang tubig, ma'am.
Okay. So, delikado siya. Baka mapuputok yung ano nyo, car nyo, di ba? So, this is what we call as application of thermal expansion. Do not overinflate the car tires and do not fill your gasoline tank up to the brim because particles of gasoline and particles of gas will expand. Same thing will happen to the road class. Bakit ginalagyan nila ng gap ang mga concrete road kung maggawa sila? This is because there is pa a space for thermal expansion. So pag mag-expand siya, at least meron pa siyang space. Okay? Ganun din sa mga bridges class. Yung kanang mga metals, usually metals usually easily expand because they are good conductor of heat. Okay? Second effect of it is change in phase. So adding heat results in the change in phase. This is another effect of heat. Okay, change in phase. So if there is an increase in temperature, that will cause the change in the structure and the movement of particles of a substance or object. So this results to the phase change. And the amount of heat required to produce the phase change is what we call as the heat of fusion. So phase change, the increase in the temperature actually changes the structure and movement of particles. So try to look at this picture or illustration. So the original state of this object is in liquid phase. So above, if we apply heat on the object that is in liquid phase, what happened to the bond? What happened to the forces between particles and particles? So na-break. Okay? So na-break na ang bond or forces, intermolecular forces between particles and particles. So pag ma-break na ang intermolecular forces between the particles and particles, what happened is these particles will now start to move apart. They will have to occupy a greater space or volume. So what happened now to the phase of this object? Since the particles are now in a greater distance, that this the result now is the phase change into a gas phase. Okay, so we all know that the distance of particles in a gas phase is greater. So magiging gas na siya. Di na siya magiging liquid phase. So this is another effect of heat if we apply. So one phase change is the change from liquid to solid. So when liquid is cooled, it releases its heat and makes the particles move slower. So the space between them is now compact. So from greater distance of particles, magiging lesser distance. Compact na sila. So pag compact na siya, what phase na yan? It's solid. And the when liquid transform to solid, this process is what we call as solidification or freezing. So when liquid turn into solid phase, this is what we call as solidification or freezing. Another phase change. Example, water turn into steam or vapor or water vapor. So when liquid is boiled, for example, evaporation takes place. So the heat now is absorbed. So water now is converted into steam or water vapor. So the liquid now transformed into gas in the process of evaporation. So the process is what we call as evaporation. Another phase change, gas to liquid. So when water vapor now release heat, its gas state change into liquid phase. One example of this is the formation of clouds. Okay? Nag-condensate. So the gas now transformed into liquid phase in the process of condensation. So the name of the process is what we call as condensation. Another phase change, sublimation. This is a process of transforming solid to gas without passing liquid. So this transformation requires additional energy. So ano yung mga example ng sublimation? Okay, yung naphthalene ball or mothball. We observe that if we're going to expose that one or leave that mothball or naphthalene ball, after how many days, what happened to the mothball or naphthalene ball? Nag-decrease na siya, nagkaliit. What is the reason or cause of it? This is because the solid mothball or naphthalene ball is transformed into a gas. Okay, nagkagamay na siya kay na from solid nag-convert na siya directly into gas without passing a liquid state. Another phase change is deposition. Okay, this is a process of transforming gas to solid without passing a liquid phase. So this transformation requires a release of energy. So an example of this is snow or when water vapor turns into ice. So from gas, okay, turn into solid. Snow actually is a solid form of. So water vapor turns into ice. This is an example of deposition. I think grade 7 teachers already discussed this one, no? It's just a review, a recall. And we connect that to the effects of heat, how heat affects the phase of matter. Okay, so take note, during phase change, the energy is given off or taking in. Okay, so pwede siyang i-give off, pwede siya i-take in ng object. So when the substance change phase, take note that the temperature do not change. So while melting, the temperature will now stay the same. Let us say, while the substance is melting, the temperature will have a same, let us say, 10 degrees Celsius, 10 degrees Celsius, 10 degrees Celsius, or 90 degrees Celsius, 90 degrees Celsius. So when it is in a process of changing phase, take note the temperature will not change. So what change is only the amount of energy changes, not the temperature. Okay, remember that. Okay, this illustration shows the summary of the phase change when heat is applied. Okay, how about heat capacity? What is heat capacity? Heat capacity is the quantity of heat necessary to raise its temperature by 1 degree Celsius. So, substance with higher heat capacity cools down slowly because they have to give off more heat, and also heats up slowly because they have to absorb more heat. Okay, a high heat capacity object usually cools down slowly and heats up slowly. So opposite, kung high siya, mas mabilis siya mag-slow down and mas mabilis din siya mainit. But substance with very low heat capacity heats up quickly and loses its energy or heat quickly. Madali din yan siya mabugnaw. So, this is an example. Okay? Let's say for example, you are cooking and you are using a wooden spoon and a metal spoon. So, sino kaya ang mas mabilis dyan mag-heats up? Mainit, ang metal or ang wooden? Ang metal spoon because they have a high heat capacity. Okay, mas madali. Pero sila din yung mas mag-cool down o mawala yung ano niya, ang lower in temperature niya. Ang wooden naman has a very low heat capacity. So therefore, mas matagal sila mainit. Okay? So this is what we call a heat capacity. How about specific heat? This is the amount of heat necessary to raise the temperature of 1 gram of a substance by 1 degree Celsius. Okay, actually, objects have different heat, specific heat. So these are the list of specific heat of solid, liquid, and gas object or substance. Okay, I think that's all. Thank you very much for listening. I hope you learned something from my discussion.